We're given a quadratic function. We'll use the vertex and the intercepts to graph the function, then we'll state the axis of symmetry as well as the function's domain and range. We have f of x is equal to x plus 1 quantity squared plus 4. This is given in vertex form. We have f of x is equal to a times the quantity x minus h squared plus k. We know hk represents the vertex. So first, let's determine whether this parabola opens up or down. Since our a is really a 1, which is positive, since a is greater than 0, we know that this quadratic function or parabola opens up. In step 2, we want to find the vertex. The vertex is just h comma k. In this case, it will be negative 1 comma 4. In step 3, we'll state the axis of symmetry. The axis of symmetry is a vertical line in this case, and it's just the line x equals whatever the x-coordinate of the vertex is, in this case, negative 1. Last, in step 4, we'll find both the x-intercept or intercepts and the y-intercept. So, in order to find the x-intercepts, we let y equal 0. Well, in this case, y is just f of x, so 0 equals x plus 1 quantity squared plus 4. If I subtract 4 from both sides of this equation, I get negative 4 equals x plus 1 quantity squared. But notice, if I take the square root of both sides, on the left-hand side I'm taking the square root of negative 4. That's not a real number. This means that there's no real solution to this equation, so there are no x-intercepts. How about the y-intercept? We can find the y-intercept by letting x equal 0. If we let x equal 0, then our y-intercept, or f of 0, equals 0 plus 1 quantity squared. I'm just substituting 0 up here in my original equation, plus 4. And this becomes 1 squared, which is 1, plus 4, or 5. Now we can sketch a graph of this quadratic function. So, first of all, we know the axis of symmetry is the line x equals negative 1. So that's just a vertical line going through the x-axis at negative 1. And we know that the vertex is negative 1 comma 4. Negative 1, 4 lies on the axis of symmetry. We also know that this quadratic function opens up, which is why there are no x-intercepts. We know the y-intercept is at 5, and by symmetry we'll have another point on the other side of the axis of symmetry at negative 2, 5. And now we can sketch this quadratic function. And this is a graph of f of x. And finally, let's state the domain and range. The domain of f, our function, is all real numbers for any quadratic function. In other words, x can be any real number, so the domain is from negative to positive infinity. And the range of our function f is any value that y can be. In this case, it's a quadratic function with a minimum value here, and it opens up, so the lowest value that y can be is 4, or y can be any value greater than 4. So the range is from 4 to positive infinity.